What's up, everyone? Today we're talking about proportional relationships. Proportional, that's probably a word you may have heard. Maybe you know the meaning of it, maybe you don't. In math, a proportional relationship is a relationship between two values where when one value changes at a certain rate, the other value changes at the same rate. So you can think of it as equivalent ratios or even equivalent fractions because these are proportional values. So let's start with a real life example where you might use proportional relationship or how this all comes into play. So many of my students, they like slime. I'm not quite sure why. I guess there is something I cannot draw today. I'm drawing my jar of slime here. Now let's say there's a slime store, and this is a special slime store where every jar of slime is equal to $5. Each jar of slime is $5. So if we're going to think about that as a ratio, we would say the ratio of jars of slime to dollars or to cost is 1 to 5. And remember this colon here represents, you could think of it as the word 2. So we've got 1 to 5. So what if I go in the store and instead of 1 jar of slime, I'm thinking this is a good deal, so I want to get 2 jars of slime. Well, how much would that cost? If you thought to yourself it would cost $10, you are correct. The question is how did you get that $10? You probably said, well, 1 jar of slime is $5, so I'm going to double the jars of slime, and I get 2 jars of slime, and I know each jar of slime is $5, so I'll multiply that by 5. So you see that? We're multiplying by 5 in each case. And then let's say one day I bring a friend to this special slime store, and they are so jazzed at all this slime and all the different kinds of slime there are. And my friend says they want to buy 10 jars of slime. Well, I'm going to apply the multiply by 5 number because I know each one is $5. And then I know my friend knows rather, that they're going to spend $50. Now, what you're going to notice is that even though the values are changing, the rate or the ratio, the rate of change is the same. And eventually you're going to learn what we call this number here. It's actually called the constant of proportionality. But without confusing you too much, I just want to focus on the fact that 1 to 5, 2 to 10, and 10 to 50 are what we would call proportional relationships. And my handwriting is also not the best today, but hopefully you get what I'm trying to say. Now, these tables come from a worksheet that I gave to my students, and I asked them to circle the tables that do not show a proportional relationship. And you're going to notice that these tables have an X column and a Y column. We're not going to get too deep into it right now, but as you learn more in math, you're going to learn that X, the value, X is the dependent, didn't mean to say that, the independent variable. And Y is what we call a dependent variable. And I know that might sound confusing, but one way to think about it is to say, well, what value depends on what? We think back to our slime example, and we recall that the amount we spend on slime depends on how many jars of slime we buy. So in this scenario, like if we were to draw a table, We could think of it, this is a very small table, so let's see if I can get it to work. So we've got slime and we've got the money that we need to spend. And slime is the independent variable, the jars of slime, I should say. And the amount that we spend depends on the jars of slime we buy. So anyway, that's just a little tidbit of information for you. Again, it's not something you really fully need to understand right now where we are in math, but I do want you to understand why we have an X and a Y. And so what I'm going to do to figure out if these are proportional relationships is I am going to say to myself, okay, well, to get from 2 to 4, I had to multiply by 2. And then to get from 3 to 6, I had to multiply by 2 also. And to get from 4 to 8, I also had to multiply by 2. So we have a constant here. We're changing at the same rate. So these are all proportional relationships. Let's go to the next table. Here I multiplied by 7. Here I multiplied by 6. This is not proportional. These are not proportional relationships, so I'm going to go ahead and circle that. These are not proportional relationships. Let's go to this next one. 3 times 2 is 6. 9 times 2 is 18, not 12. So this is also, right off the bat, we know this is also not a proportional relationship. Go to the next one. 8 times 3 is 24. 3 times 3 is 9, and 1 times 3 is 3. So these are all proportional relationships. We'll go to the next one. 2 times 2 is 4. 8 times 2 is 16, and 32 times 2 is 64. These are proportional relationships. Let's just do one more, just for kicks. Here we've got 10. 10 times 2 is 20. Here we've got 20 times 2 is 40, and 40 times 2 is 80. So these are proportional relationships. And, okay, let's just do one last one. Here, 10 times 2 is 20. 30 times 2 is 60, not 40. So these are not proportional relationships. Now, as you look at the last three, do you know right off the bat what would not be a proportional, which table does not show proportional relationships? If you thought to yourself, this table here, you would be correct. These are all times 3, these are all times 4, so these are proportional relationships. Now, this is a word problem that I gave to my class. It says, if the ratio of cats to dogs is 2 to 3, how many cats will there be if there are 27 dogs? And how many dogs will there be if there are 20 cats? Well, we've learned a little trick. We can find out if these numbers are constant, and I'm going to show you another way when we're dealing with numbers that are a little harder to work with. So if you know your multiplication facts, 0 to 12, then that's great, but we're right now dealing with a fraction. To get from 2 to 3, what do we multiply by? It's a little bit harder. So one way to solve the problem is we could turn it to a fraction. Turn it into a fraction. And we could say 2/3 equals 1 to 27. Now 2/3 can also be thought of here as 2, 3, with the fraction bar denoting the word 2. 2 to 3 equals what to 27, which equals 20 to what? So we've got these question marks here. Well, let's get to work. Here I know that 3 times 9 is 27. So whatever I do to my denominator, I do to my numerator when we're dealing with proportional relationships. And because we have a set ratio here, we know that we're dealing with proportional relationships. 2 times 9 is 18. So I know that if the ratio of cats to dogs is 2 to 3, then if we have 27 dogs, we have 18 cats. And now, let me work my eraser here. We're going to go to the next one, which is, oops, didn't mean to do that, which is we want to find out how many dogs are there if we have 20 cats. So we're going to go 2 to 20. I am multiplying by 10. So I'm going to multiply the denominator here by 10 and we get 30. And the answer is going to be 30. So to answer this question, I will have, if I have 27 dogs, I will have 18 cats. And if I have 20 cats, I will have 30 dogs. All right, let's go to a slightly harder example. Again, a problem I gave my class. If Kai babysits for 1 hour, he earns $15. How much money will Kai earn if he babysits for 5 hours? And if Kai earned $150 last weekend from babysitting, how many hours did he babysit? Well, if you are presented with a problem like this, you can always draw a table as the one shown. Here it's already drawn for you. But let's say if it weren't drawn for you, you could actually make it yourself. So we know that the ratio of babysitting hours to money earned is 1 to 15. We've got that information. And we know here we're multiplying by 15. So if we know, and again, we can also use the fraction method, but we know 1 times 15 equals 15. So now we're going to multiply by 15 here. So 5 times 15 is what? Well, 5 times 5 is 25. I'm going to carry the 2. We've got 75. So if Kai babysits for 5 hours, he earns $75. Now, what about if he earns $150? How many hours did he babysit for? Well, we know again, we're going to multiply by 15. And what do you notice about 150? I know by looking at it that 10 times 15 will equal 150. Another way to think about it is 150 divided by 15 is going to equal 10. Not sure if you've learned how to multiply by powers of 10. If you do not know how to do it that way, you can always do it out using long division or other methods. But now, as you can see, I've got my answers. So it says, how much money will Kai earn if he babysits for 5 hours? Kai will earn $75 if he babysits for 5 hours. And then it says, the question asks if Kai earned $150 last weekend from babysitting. How many hours did he babysit? He babysat 10 hours. And one last thought, I'm going to actually erase the work that I had. One last thought is, and we're going to get into this in our next video, we're going to see that this number that we are constantly multiplying by, in this case it's times 2, times 2, times 2, these are proportional relationships. So that number that we are constantly multiplying by when you have a set of proportional relationships is called the constant of proportionality. And you can think of the constant as the thing that doesn't change. And I'm going to stop right there. That's a lot of information already. And I hope this all made sense to you. And until next time.